Hey friends, it's Kaylin, Riley, and Zelda's gonna help out too. We're gonna talk about solving linear systems. So solving linear meaning line, and system just means there's more than one. So like a solar system has more than one planet. So when I'm solving a linear system, I am looking to see where do my lines intersect. So two lines can intersect at a single point. They can never intersect, or that could be a possibility, and that could only be a possibility if they are parallel lines. Parallel lines have the same slope, or they could be two lines on top of each other at every single point, so that would be infinite solutions. So 1, 0, or infinite solutions. So how do we solve? How do we find where they could possibly meet? Three main ways: graphing it, and then finding the point, plugging that point back in, and checking to see if it works using a method called substitution and a method called elimination. Make sure you also remember that solving a system means I'm looking for the x, y. What's the coordinate in which they intersect? Okay, I need to have an x and I have to have a y. All right, so with graph and check, I need to make sure that my lines are first in slope-intercept form, so it should look like y equals mx plus b. If it's in that form, then I could either just graph it by using the y-intercept and the slope, or if I want, I can use a function chart. So let's use the first one. So 2x plus y equals -5. So all I have to do is subtract 2x from both sides. So I have y equals -2x minus 5. And I'm going to put a box around that because we're going to graph it. So I'm not finished. I'm just saying that's one of the lines in which we're going to graph. The second line, -x plus 3y equals 6. Got to get y by itself. So I'm going to add x to both sides. So I have 3y equals x plus 6. Make sure that when you get y by itself and you divide by the coefficient in front, you divide each of the terms. Okay, so everything is getting divided by 3. So y equals 1/3 x plus 2. All right, so for the first equation, I'm going to go to -5. 1, 2, 3, 4, 5. I'm going to go down 2 to the right 1 for my slope of -2. Okay, so that's the same thing as going up 2 to the right 1. It's so hard to see on here. Okay, and then I might have to go a little bit further. And then my second equation, I'm going to start at 2, 1, 2. I'm going to go up 1 to the right 3, which is the same thing as going down 1 to the right 3, down 1 to the right 3. And it looks like they're meeting somewhere around here. If I had better eyes and a bigger screen, I could tell you exactly what it is. But let's just pretend that we think it's 1, 2, let's just say -3, 1. Okay, it looks like it's -3, 1. I'm not entirely sure, but that's why we're going to check it. So to check it, I'm going to put it into both equations and see if it works. So 2 times -3 plus 1. So I'm plugging into this first equation here equals -5. Is that true? Yeah, -5 equals -5. So it works for the first equation, but I have to make sure it also works for the second equation. So negative, so I'm going off of this, so negative, and then my x value, so -3 plus 3 times 1 equals 6. Does that work? 3 plus 3 equals 6? Yeah. So that seems like it works. So this method worked, and I do know that this is my solution, but it may not be the most efficient. Okay, again, it was just a little bit small. My eyes aren't too great. I did check it to make sure, but these were just really nice to graph. I didn't have like fractions or anything from my y-intercept. So this would be the first method in which I could potentially use. In the next video, we're going to talk about the two other methods that you could use without graphing